Hello, everybody. Hi, everybody. Welcome to our event, Understanding Nitrates in Nebraska with Dr. Shannon Bartelt-Hunt. Happy Monday. My name is Morgan Alonji. I'm an AmeriCorps member with Conservation Nebraska's program. And a few things to go over for this Zoom session. Your cameras and microphones will be off, so we will not be able to see or hear you. If you've got any questions tonight, there's a Q&A section that you can just put those into there. Towards the end, ideally, we'll have a few minutes and we can go over some of those, hopefully get some answers for everybody. And towards the end of the Zoom, we will be sending out a poll that we'd appreciate if you guys don't mind taking. These help us plan for future events and some other things that we've got going on for Conservation Nebraska. So if you guys are ready, I will hand this over to Dr. Shannon Bartelt-Hunt and we will get started.
Okay, great. Thanks so much, Morgan. So I'm going to go ahead and share my screen. I have probably about 20 minutes of things to talk about, and that'll leave us plenty of time for questions. I'm going to turn off captioning. So if you have questions, please go ahead and start putting those in the Q&A. And if something pops up that is better answered at the moment, please, Morgan, just go ahead and stop and we'll answer that at that time. So today I'm really happy to talk to you about understanding nitrate in Nebraska. Again, my name is Shannon Bartelt-Hunt. I'm a professor in the Department of Civil and Environmental Engineering at the University of Nebraska-Lincoln. So we're going to talk about nutrients today, specifically nitrate. And just a little bit of background. Obviously, we live in a state that has a lot of our communities surrounded by agriculture. So there's a lot of potential for our water to become contaminated by either manure or conventional fertilizers, both of which contain nutrients that are nitrate and phosphate. There are other sources for nutrients as well. We apply nutrients, fertilizers to our lawns and urban settings, but the majority of where we're applying these compounds are in for agricultural production. So we need these nutrients to grow plants, but the issue arises when we have excess nutrients. They get into water, they can cause adverse health impacts and also just adverse environmental impacts. And we know that we need good water quality for our own health and also for the health of the environment. This map over here just shows the darker the color just shows how much nitrogen is moving through that particular watershed across the United States. And you can see kind of where we are in the middle in the Corn Belt is kind of under some of these darkest areas for nitrate flux. And so we know we do have a lot of nitrate moving through our watersheds in Nebraska. So how nutrients can enter water. First, nitrate and phosphate nutrients are present again in chemical fertilizers and manure. So when it rains, when we've applied these compounds to, or applied, these substances to land, and it rains, it can carry off some of that excess nutrient into surface waters, like our streams, lakes, and ponds. Also, when rain infiltrates and we have those materials on the ground surface, it can carry them down toward plant roots, which is a good thing. But then if there's excess, it can go past the plant roots and continue moving down toward our groundwater aquifers. So we have concerns about nutrients, both in surface water as well as in groundwater. We know also that the state of our environment definitely impacts our public health. So one of the issues with nitrate in Nebraska is that it is regulated by the EPA for some of the health concerns that can come about if you drink water that contains nitrate in excess of the standard of 10 milligrams per liter. We know across the US, there's 15 million households that rely on private wells for drinking water. Most times when you have a private well, there's not a requirement for testing. It's just up to the homeowner. There's definitely a recommendation that you have your well tested at least once per year. And if you have questions about that, I'd be happy to talk about that in the Q&A. And so in this study that was published a number of years ago now, they looked at two things. First, how much nitrogen was available to move to groundwater, and then also just the vulnerability of the aquifer. And you can see here in Nebraska, we are across much of the state in areas of high nitrogen input, as well as high vulnerability of our aquifers, and that corresponds to these red areas. And so we have a lot of potential over a lot of the state for nitrate to come down into our groundwater. And in another study published by the USGS, they estimated that about 20% of private wells contained at least one contaminant at levels that were a public health concern. So that's, a very large percentage. And then unfortunately, it's just up to individual homeowners to try to determine that. And also, if you do detect contaminants in your well, then how those can be removed so that your water is safe to drink. So in the state of Nebraska, we have a lot of water quality information, but one of the challenges is that we don't have water quality information everywhere across the state. So this is a map published by the NDEE, and each one of these pixels is a township, and just showing the median nitrate concentration across the townships in the state. And something that's important to note, that the gray townships means there are essentially no data available for that location. And so that's important because you can see there's quite a bit of area across the sandhills, but also in the eastern part of the state where we just don't have water quality information. The other thing you can see here is that, again, that drinking water standard for nitrate is 10 milligrams per liter. So if you look at these kind of light orange is on the verge of that 7.5 to 10, and then the dark orange, red, and purple all exceed that drinking water standard. You can see in these townships where you see those colors, the median nitrate is actually exceeding the drinking water standard. So that is definitely of concern. And you see that along the Platte River and then also in kind of northeast Nebraska. So one thing we wanted to do is to start filling in some of those gaps in water quality information across the state of Nebraska. And so starting in 2018, we started to measure nitrate concentrations and also phosphate concentrations in private wells and surface water. We started in eastern Nebraska, but we've since expanded across the state. And so we have recruited hundreds of people, and we call them citizen scientists, who measure surface water and well water samples. We provide training. And the goal of this program is just to provide people more information about their water quality, especially if they have a well and want to get some initial information on the quality of the water that they may be drinking. So how the tests, so we use these water quality test strips, which are very straightforward to use, and they are quantitative. So they do give you a concentration. And so there are two test strips that we use. One measures nitrite and nitrate, which are two forms of nitrogen. Nitrate has a drinking water standard of 10 parts per million, and nitrite has a drinking water standard of 1 part per million. There's two pads. And so when you dip the strip into your water sample and then hold it flat, these pads will change colors, and then you can compare them against this color chart that's provided. And you can see based on those colors, you can read off the level of either nitrite or nitrate that's present in your water sample. So you get immediate information when you use this test strip within about 1 minute. We also ask participants in this program to measure phosphate, although I won't talk as much about our phosphate results. Phosphate is important because it causes environmental health issues, but there's not a drinking water standard for phosphate because it doesn't cause health issues. So things that phosphate can lead to are things like algae blooms and other kinds of environmental impacts. So we're concerned about phosphate in the environment, but there's not a direct human health impact of drinking water that contains phosphate. So very similarly, it also has a single colored pad. You can submerge the strip in water, hold it flat, and then again, compare the color against what you see over on the color strip. So here's some of our more recent data. We've been conducting this study since 2018, but I thought people would be interested in seeing some of the most recent data from this past year, 2013. And so we ran our program in the spring in May of 2013. We always run it in May and usually September. And so we have two testing periods per year. And so this map just shows across the state of Nebraska, we had a total of 208 water quality tests that were performed. And you can see the well waters are red circles, and the size of the circle corresponds to the concentration of nitrate that's present. So a bigger circle indicates more nitrate. The triangles are surface water. And again, the bigger the triangle, the higher the concentration of nitrate. We had about 60% of the samples that were tested were wells, and about 40% were surface water. Of those 208 submissions, they were submitted by 139 individual citizen scientists. And we were fortunate to have people testing water in 21 of our natural resource districts across the state. And then in the fall of 2023, you can see similar data, about 70% wells, about 30% surface water, and this is more limited. This is data pulled through the 9th of November, so we will update this. We believe we have more samples coming in from fall, but again, you can kind of see spatially across the state where we're seeing larger circles corresponds to higher levels of nitrate measured in wells. And just kind of looking at the size, you can definitely see wells that are exceeding the drinking water standard of 10 milligrams per liter. So in terms of, this graph shows 2022 as well as 2023, and it just shows the total numbers of people who have participated, which we're very happy, that we have over 100 participants each time we run the program. In some cases, over 300 participants, and roughly about 70% of people are measuring well water, and about 30% are measuring surface water. And over the past 2 years, we've collected almost 900 water quality data points across the state, which is really fantastic. So just looking at the data, there's a lot going on in this chart. So this just shows you across the different samplings, spring of 22, fall of 22, spring and fall of 23, these numbers correspond to what percentage of the samples that were tested were in different categories. So nitrate below 2 milligrams per liter, just about half of the samples measured nitrate at 2 milligrams per liter or below. And so that means if you look across these columns, the remaining samples were also just about half measuring at these various levels. So things we'll look at, the percentage of samples that measured at or exceeding 10 milligrams per liter, which is the drinking water standard, is actually maybe slightly increasing from about 18% of wells to about 24% of wells in the fall of 2023. In terms of surface water, we're actually seeing an opposite trend where we're seeing, as we move across spring to fall, a smaller percentage of surface water samples measuring above the drinking water limit, but this could also just be because we were having less surface water being measured in the spring and especially in the fall of 2023. So in general, we see lower concentrations of nitrate in surface water relative to groundwater. And in groundwater, we're seeing, a pretty high percentage of wells that are about a quarter of the wells that are exceeding the drinking water standard. So our kind of what we can learn from this program, 20% of wells are exceeding the nitrate standard. Just about half of the wells have nitrate concentrations greater than 5 milligrams per liter. So this just tells us, as we already know, that nitrate is something that we want to carefully look at in Nebraska. And if you have a drinking water well, we highly recommend testing. And in terms of how to do testing, you can, participate in this program. We consider it kind of an initial screen. So if you participate in this program, find that you are getting a result testing 5 or 10 milligrams per liter, we definitely recommend that you follow up by sending a sample to a certified lab. There are some web resources that I can pull up during the Q&A that have a list of certified labs that can be accessed across the state. And, I think the important thing is that people know how to test their water, realize that they should do that on a yearly basis, and identify what they should test their water for. And many times nitrate should definitely be on that list of contaminants that are being tested. So we will be recruiting again for a testing window in May of 2024. So if you'd like to sign up after the first of the year, you can go to this website, go.unl.edu/WQCS to get signed up. And if we continue monitoring, it will allow us to fill in some of those gaps in our data and collect information on water quality over time. And so with that, I'm happy to acknowledge the funding for this project, partnerships with various NRDs, as well as Conservation Nebraska. And I think that gives us a lot of time for questions in the Q&A. So I will be happy to start answering those.
All right. So it looks like someone is asking, why not apply plasma ozonized water through pivot systems? This will eliminate the use of chemicals, sustainable growing of our crops.
Yeah, so I think that's, definitely one of the questions. Currently, we use a lot of groundwater for crop irrigation. And when we have nitrate in our groundwater, then that nitrate is, applied to the crop surface and brought up to the ground surface. One of the issues can be, potential for treatment of that water. That does introduce an additional cost and might affect the cost of growing those crops. But certainly as nitrate concentrations grow in our groundwater, that may be something that needs to be investigated.
Fantastic. We have another question from Liz. It says, what does remediation look like if nitrates are high?
Yeah, so if you have a home well and you have high nitrate, there are a couple of different options, such as reverse osmosis or filtration that can be installed at the household level. The state actually right now has a rebate program to help get, I think, RO systems into individuals' homes when they do have high nitrate. And so that's a great opportunity, but usually those are the treatment options. It's either something like reverse osmosis or filtration. So we definitely have good technologies. It's just people have to be aware if they do have high nitrate to get those put in place. And of course, there's a cost associated with that. And so that cost is something that the state is trying to address.
Next, we have another question. We have quite a few questions. Our next one says, how are the townships that have very high nitrates currently treating their water, especially with the high cost of treatment on a per user basis?
Yeah, that's a great question. So I think that's really important. And there's kind of another comment that kind of goes along with this in the chat, the webinar chat. And so first of all, if you're on a public water supply, like a municipal water supply, like City of Lincoln or another city, that water is required to be treated to meet the EPA standards. So there really are not concerns about that water exceeding, nitrate levels. Now, that being said, the source water that might be being used may have high nitrates. And so I think what the question is asking is, how is that nitrate being removed in surface water treatment plants? And it does cost a lot. There are filtration systems essentially that can be used at that municipal level, just like at the household level, but they are quite costly. I think if I recall, the city of Des Moines was having some issues because they use a surface water source. And I think it was costing them on the order of $1 million per day when they had to turn on that filtration system. So there are technologies, and for municipal water supplies, they're required to deliver water to your home that does not violate any EPA drinking water standards, but there is a cost associated with that, certainly.
All right. Next, we have, what is the source of nitrate in the groundwater?
Yeah, it's a great question. So the nitrate that we are seeing in groundwater is coming from the surface, the ground surface. And so it's coming from application typically of nitrate, either in manures or in chemical fertilizers, from agricultural application, or from application in households, lawns, golf courses, etc. And then if that nitrate is not taken up by plants, I mean, the goal is to apply just what the plants can use. But there are sometimes that form of nitrate that's applied isn't completely bioavailable to the plant, or if it rains right after the manure or fertilizer is applied, it can wash off into surface water, or it can infiltrate down into the ground. So it's typically from some type of human activity on the ground surface, and then it trickles down into the soil and eventually into groundwater.
Okay. I believe you've kind of already answered this, but the question says, what is done to reduce the nitrates in ground and surface water?
Yeah, so there's been a lot of work done by many different entities, including, agricultural producers are definitely trying to limit the amount of nitrate that's applied. NRDs are trying to limit the amount of nitrate because there's also a cost. No one wants to over apply nitrate. And so I think that has helped. I think not applying, fertilizers or manures, especially manures on frozen soils, is a good practice. So that, again, that can't just wash off of the surface into surface water. Put installation of things like buffer strips or other types of areas that can help filter some of that nitrate out of water when it's running across the surface can also be very valuable. So it's just a combination of changing our practices of how we apply nitrate, changing the form of nitrate. So there's some evidence that nitrate in manure is maybe more accessible or more available than commercial fertilizers. And then also having some of those practices in place in agricultural settings to kind of filter that nitrate or remove that nitrate out before it reaches surface water.
All right. Another question, it says, why has the safe level of nitrates been set at 10 parts per million when vegetables have far higher levels? And they type in parentheses here, V8 juice is 26 ppm, spinach is high, and even human breast milk is 80 ppm.
Yeah, so the way EPA sets those risk assessments is that they'll look at how much of that substance, such as water, is consumed by a person on a daily basis. And so you may have things like you mentioned, juices or foods that have higher levels of nitrate, but the EPA can look at how much water you can expect someone to consume. And because we, need to drink a lot of water for our health, then they can kind of back calculate what that safe level is. And that's how they've arrived at the 10 parts per million. And it's a much more complicated process than that, but it's basically taking into account how much of that we're exposed to in our water on a daily basis, and then backing out what that safe level is based on an acceptable risk. And that's a process that the EPA uses to set these drinking water standards.
Okay. We have quite a few more, so this is great. What are the best practices local NRDs are using to source new water when rural water supplies test with high nitrates?
Yeah, so that's a great question. Usually the best practice is to try to access a deeper aquifer. So if you're using groundwater, typically the nitrate will first impact more shallow groundwater aquifers. So oftentimes it may be looking at a deeper aquifer as a way to eliminate nitrate in groundwater.
Perfect. This one also ties in with the NRDs. Joe is saying that my understanding is that NRDs are responsible for initiating action to address high levels of nitrates in groundwater. Do we have examples of NRDs taking effective action to address high nitrates?
Yeah, I think that's a really good question. In terms of regulatory, I actually don't know if it's the NRDs or NDE. That's where, the ones that come and might actually address like take a regulatory action. And I think that there are a lot of challenges. So with nitrate, because it is what's called a non-point pollutant, meaning the nitrate that's coming into our water is not coming out of a pipe that can be easily regulated. It's coming from across the landscape when it rains, or infiltrating down into groundwater. So I think that there are nutrient management plans that NRDs and NDE do put in place and enforce. And so I think they really are trying to work on limiting the amount of nitrate that's put on the ground. I think that's important. And then I think why we're seeing nitrate in water is because it does build up over time. And so we have many, many, many years of nitrate application that's just kind of moving through our soil and reaching groundwater.
Fantastic. Another question here is asking, what are ways that you've seen success when talking with farmers and agricultural producers about reducing fertilizer usage? How do we get them to care when no one is being held accountable?
Yeah, so that's a good question. I don't always directly speak with producers, but I do think that there is increasing awareness about over application of nitrate and fertilizers. Certainly there's a cost to doing that. Fertilizers are expensive. And so, you can definitely talk about the costs and producers wanting to limit some of those costs. I think there's also, I think the NRDs work on that with producers through nutrient management plans. And I think that's an important step in the process also.
Fantastic. Our next question, it says, please explain why fall nitrogen application is not recommended.
Yeah, so I think the reason there is because typically we're taking crops out in the fall. And then often the, ground becomes more dormant. So if we apply nitrogen at that time, it's not able to be taken up by plants, and then it can sit on the ground surface and then just move down toward groundwater or wash off. And so I think those are the reasons why fall and winter application are not recommended.
All right. Our next question is just asking, does the distiller take out nitrates?
Yeah, so if you're kind of referring to like a reverse osmosis, or if you have a water distiller like in your home, yes, it would remove nitrate from your water. RO and filtration are two really effective techniques for removing nitrate.
Fantastic. Our next question is asking, what is being done to lower the EPA MCL standard to be more aligned with current medical research that suggests harmful levels even below 5 parts per million?
Yeah, I think that's a really good question. So, a little bit of background here is that there are studies that are showing that there can be effects of consuming nitrate at levels below the standard that's 10 parts per million. So some studies showing effects at like 5 or even 2 parts per million for sensitive groups like children. And so I think that I'm not sure that there is a lot of, well, I shouldn't say that. I'm not sure I'm aware of a lot of activity that's specifically looking at the nitrate standard, but I do think when more studies come over time showing the potential for health impacts, then it is something that EPA probably looks at lowering. There have been other standards that have been lowered, such as the arsenic standard. And so I think that when there's enough, data showing that there can be impacts at those lower levels, and they might go back and revisit that standard.
All right. Our next question is, what happens to nitrates that are filtered from public water systems?
Oh, that's a really great question. So typically, there's some type of filtration media that those nitrates are transferred to. So it's usually a solid. You could think of it like activated carbon. It can be very similar to like the insides of a Brita filter, just on a much, much larger scale. And so the nitrates move when it passes through that type of filter, they move from the water to, and they attach to that solid filtration media. Sometimes that filtration media can be regenerated, and those nitrates might transform and actually form something like nitrogen gas and just be released to the atmosphere, or that filtration media can be disposed of in a landfill. So those nitrates are disposed of in that way so that they don't go back into the water at some point.
All right. Our next one is asking, are the people responsible for the over application of nitrates liable for the water pollution that is created?
Yeah, it's a really, really great question. And so I would say the answer is not directly, right? So because nitrate is typically, again, what's called a non-point source pollutant, meaning it's just coming from various locations, it's very difficult to pinpoint if we see nitrate in a water body or in the groundwater, it's really difficult to track it back to exactly where it came from. So it'd be really difficult to establish that type of liability. And so this is why it's really a tricky problem, because it really involves lots of different strategies, education, regulation, but there isn't sort of a direct way to say, facility A contributed to this nitrate that we're seeing in this aquifer or in the surface water body.
Right. Perfect. While we are answering questions, guys, I'm going to ask Kat to also launch a poll for attending today. So as we're going through some more of these, if you guys don't mind doing that little survey for us, that would be wonderful. And it should be up for you now. My next question, it says, are regenerative farming methods to reduce or eliminate chemical fertilizers promoted by university or other entities in Nebraska?
Yes, I believe they are, and I think kind of going down a couple more comments as well in the chat, I do think that there's a lot of activities being taken by producers and farmers to limit nitrogen inputs. And, I think that this is something where people have learned over time what some of the impacts are, and then they're wanting to take steps to address that. And so, yeah, I think that there are many strategies, and they are being promoted by different groups, looked at by researchers, and then put into practice, by farmers and other producers to limit nitrate.
Okay, perfect. Our next question is asking, are nitrates absorbed through the skin or inhaled through the air? And is this a health issue?
Yes, so nitrate can cause some health impacts. One of the most common is called methylglobinemia, which basically means that your body doesn't absorb oxygen in the same way. Um, and there's other potential linkages to different types of cancers, although those are not directly they're kind of indirect correlations, not direct linkages. So most nitrate exposure is coming through food or water. If you were, recreating, bathing in water that contained nitrate, I think some would be absorbed through your skin. It's not volatile, so it isn't something that you would be concerned about in the air.
Alrighty. Our next question, how and when did nitrate and other farm chemicals become designated as non-point sources of contamination?
Sure. Yeah, that's kind of a technical term that basically just means that that compound is not coming from like a effluent pipe like you might see at a industrial facility or something like that. It's coming just from application on the ground surface, and then it's carried with precipitation. And so it's not I guess not a specific like regulatory designation, but it's just the way that the chemical is applied and released.
Right. Here. Okay. Next, let's see. Have you seen any discussion of electrochemical reduction of nitrate for water treatment on the municipal level? Excuse me. It's a developing technology that is not yet large scale from my knowledge. As a PhD student studying this topic, I'm curious if it is on your radar.
Yeah, that's a great question. I'll have to admit it's not something that I have a lot of direct experience with, but um, I think that there are a lot of techniques that can be used to remove nitrate, and so it's important that we do have research and demonstration projects where we can evaluate those. So yeah, beyond filtration, there are a lot of different technologies that can potentially help us with removing nitrate.
Fantastic. Another question we have is, can you talk about nitrite versus nitrate?
Sure. Like in a nutshell, nitrite and nitrate are two different forms of nitrogen. When we have nitrogen in the environment, they are microbially transformed between these two different forms. And then they can also be completely mineralized to nitrogen gas. And then that's actually removed from the water and moved into the atmosphere. There's just different health impacts of those two different forms of nitrogen. So nitrite has more health effects, and that's why it has a lower MCL of 1 milligram per liter as compared to nitrate. But nitrite is not commonly found in the environment. It's more common that you might have exposure to nitrite from things like eating processed meats and other. Nitrite is often used as a food preservative. So there's probably more potential for exposure to nitrite through that than through environmental nitrogen.
Fantastic. Another question we have here, what's the connection between nitrate runoff and green algae blooms in lakes?
Yeah, I think that's great. We didn't talk a lot about that. So in general, like I mentioned before, nitrate and phosphate are nutrients that plants require for growth. The issue is when we have excess, that can lead to kind of a runaway growth of certain plants like algae in water. And so when you have too much nitrate, too much phosphate, that can then lead to kind of this explosion of algae that can cause other types of issues. So one thing that algae does is it uses up all the dissolved oxygen. that can be present in water. And then that obviously makes it that water not habitable for fish and other organisms. And then the other thing it can do is sometimes algae are what are called toxic algae, and they can release toxic compounds, and that those can be harmful if people are exposed to them or animals are exposed to them. So there's a direct health issue from consuming nitrate. And then there's also an environmental health issue, which can be these algae blooms, which can then lower dissolved oxygen and lead to production of toxic algae.
All right. And our last question, unless anything else trickles in here, is it not crucial that Nebraska react very serious to our nitrate and water problem? It has resulted in the highest pediatric rate in the USA.
Yeah, so I think that is referring to the fact that Nebraska does have a very high rate of pediatric cancer per capita. I think that's a very, very serious issue. You've been working with a group of faculty and doctors at UNMC, and there's certainly a genetic component to development of cancer, but there are also environmental factors that can, result in development of cancer. And I think there's a lot of interest and concern on the part of pediatric oncologists who work with these patients to understand what some of those environmental factors might be and why Nebraska does have this higher rate on a per capita basis. So it's something that we're looking into, and definitely one of the areas we're investigating is broadly agrochemicals, which can include nitrate, but also can include things like atrazine or other chemicals that we use for agricultural production.
Fantastic. All right. I am not seeing any more questions at this point. So I would just like to take a minute to thank everyone who's attended and Dr. Shannon Bartelt-Hunt for that presentation tonight. I certainly know that I have learned something. I hope everyone has taken something away from that. And yeah, I have nothing left unless you do.